Okay, so good morning once again. Today we continue our discussion on regression diagnostics for the wage dataset that we were using last time. So what we're doing now is we're creating a new R Markdown file because our previous R Markdown file has contains so many codes already, and it contains the stepwise regression. So we'll just pick it up from where we ended with the final model, the model number 5, okay, which is, let me show that here. Model number 5 is our fifth model, and it's the hourly wage regressed on, okay, so this one, hourly wage regressed on education, tenure, gender, civil status. So out of the 7 regressors, we only have now 4 regressors. 3 were eliminated using in stepwise regression. Okay, so we copied this. Sorry, the model. Okay, now I'm going to, I was looking for some references by which we can outline the regression diagnostics. I saw some good ones. So what we're going to do is we're going to refer to this site, and then although it's using another data, we're going to follow along with this discussion of this regression diagnostics and use it on our data. Okay, so let me paste here. Let me close this first. There are so many open tabs here, and it might be affecting my. Okay, so let me close this. Okay, there's a good site. This one, it's in RPAB. So let me share the link with you. Control C, and use this as a reference. There are other good references. So, but let's just use this for the meantime. Now, when I do some research on how best to, let's say, do regression diagnostics, I usually use several references. I do not just satisfy myself with one reference. I get the good points of one and then combine it with the good points of the others. So what we're going to do now is we will see how this module on regression diagnostics is done. This was done by Roel Ceballos, and the objective is perform the different regression diagnostics in R and learn how to use appropriate criteria in choosing the best model. Okay, so kindly please chat if you have already access. And there's another one. Okay, let me share that also. This one is also a good reference. There are several good references, but of course we cannot use all of them. So let's just limit ourselves to a few. Okay, I'm sharing 2 references. One is a textbook, a book down. This one. Okay, this one is a textbook in R, used book down. So there are now many textbooks that's being printed in R Studio through the book down package. So this is a book on, the title of this book is Quantitative Research Methods for Political Science, Public Policy, okay, and Public Administration for undergraduates. Although this is a book for political science or public policy, but it deals with quantitative research methods. So the text is very good. Okay, if you take a look at the several chapters, chapter 4 is the use of R. Chapter 5 is descriptive statistics. Chapter 7 is inferences. And then chapter 9 is OLS, ordinary least squares. Chapter 11 is assumptions. Okay, we're going to take a look at this also. Okay, because here you have in chapter 11, you have the assumptions. Okay, assumptions of OLS, and then it tells us of residual analysis, which is what we need. Okay, so we will navigate through these two resources and follow the codes that they're using our data. Okay, but if you're interested also to follow along, for example, for this one, in chapter 4, you will find there how to, okay, chapter 4, uploading and reading data. You will find here that the data that used in this book can be downloaded here. Okay, if you're interested to follow along this book. Okay, so as I said, we don't have a lack of resources. Okay, there are so many resources that we can follow along, follow and use to enhance our understanding. Okay, so one of them is this one. Okay, so this is a subject, Stat 312. Okay, so let's, I will not, you may wish to copy this in your R, but I suggest not at the moment. Later on, you can copy this and paste it in R. Okay, so what we're going to do now, let's see if I can I increase the size of this? Okay, there. Okay, so we're going to look at regression diagnostics. Okay, we said that when we do multiple linear regression, the method that's used is OLS, ordinary least squares, and OLS follows certain assumptions. At the end of the process, when we have identified our final model, we do not stop there. We have to assess or diagnose whether our model followed or was in tune with the assumptions. Otherwise, if not, then we have to check. Okay, so this material is all about regression diagnostics. First, it takes a look at outliers, unusual and influential data, and then it gives us a brief guide in how to remove outliers if possible. And then we deal with homoscedasticity, linearity, independence, normality, multicollinearity, and model specification. So these are the subtopics that we need for regression diagnostics. So again, as by way of review, what are the assumptions of OLS? Number one is homoscedasticity of variance, homogeneity of variance. I mean, the error variance should be constant. Okay, if you plot the variance, let's say the residuals over the fit values, there should be no pattern. Okay, we have shown that. I think if we refer to this one, okay, so let's navigate through both references. All right, so this is an example of, this is your residuals and this is your fit value. If you notice, it's like when you sneezed on the residuals, when you sneeze, umatsing kayo, diba, kakalat yung residuals. And there will be no obvious pattern, random lang siya. So that's what the residuals should look like. Ito yung homogeneity of your variance. Okay, your variance is not increasing over time, neither is it decreasing over time. There's no pattern, parang U-shaped siya or inverted U, okay, which is indicative of perhaps a model that's not linear. Okay, so this is how your residuals, the pattern of your residuals should look like. Dapat wala silang ano, ito yung sinasabi natin, ano? They should appear as a sneeze plot. Okay, it looks like you sneeze on the plot, of course, gross down. No? All right, so balik tayo dito, no? Second is that the relationship between the predictors and your dependent variable should be linear. Okay, and we can see this in the correlation plot. Okay, And ito, guys, this will this can lead to this one, heteroscedasticity of your error terms. Kapag heteroscedastic yung residuals natin, then it can be indicative that it's also indicative, it may be indicative that the relationship between our variables, our independent and dependent, is not linear. So maybe to remedy that, maybe we can introduce another variable, which is let's say a square of the independent variable. That's just one example. Okay, independence, the errors should not be associated, are not correlated with the errors of any other observation. So this is more autocorrelation, okay, autocorrelation of the error terms, and this is more apparent in time series. Not so much in cross-sectional series, because in cross-sectional series you can rearrange the pattern. And then we have the normality of the residuals. Okay, technically, normality is necessary only for hypothesis tests to be valid. So there's a way around this. If the error terms are not normally distributed, they are not really part of the required or very strict assumptions of classical linear regression model. And another one, model specification. The model should be properly specified. Okay, it means there are no missing variables. Okay, if you have some modeling, for example, if you were modeling our problem, for example, hourly wage, and we have shown that education is an important predictor for hourly wage. What if education was missing in our data set? So that's an example where there is missing data. And if there's missing information, missing relevant variable, then we have an issue called model specification. Okay? All right. So, and then additionally, there are issues that can arise during analysis that, while strictly speaking are not assumptions, are nonetheless of great concern to data analysis. So for example, yung influence. Okay, so the presence of observations that that are outliers, and then the presence of which highly affect the coefficients, the results of your regression model. Okay, and then also collinearity, predictors that are highly collinear. Okay, so we want that the independent and dependent variable are highly collinear, highly correlated, but not the independent variables. Okay, so the good thing is this is based on R. R has many of the methods in several packages. Okay, so we're going to here, it uses CAR, ALR3, and far away. Okay, we're also going to use this one, which uses what packages is used here for, okay, for regression diagnostics. Okay, dito car package dito. So here we have also examples of testing for non-collinearity. So we will also take a look at this. Together, these two, okay, we can combine it and work on our data. So let's copy this. Okay, and add it to our model. All right, so Control D. CAR, okay, not yet there, ALR4, and far away. And before we continue, the CAR package I think we have used before, but anyway, let's just for the package, oh no, let's just, okay, ALR4, I don't think we have installed this, and far away also. So why don't we install that here first? Install that packages. I should have copied. Okay, I should have copied the code. This one. Okay, let's copy this. Control C. And let's just run it in the console, Control V. And let's remove the comment sign. All right. I don't think, I think I have far away already, but for your purpose, guys, let's just install this error. Why error? Okay. Let me see what's the error installing, install that packages. Updating loaded package. And when you're done, class, kindly please chat yes if you're done installing these packages. I will not install car anymore because I think you also have car in your, we have downloaded that before. Okay, then I load this history library. Okay. All right, please chat if you're done. Okay, thank you, James. Let's wait for the others. Feedback, please, from everyone. Okay, good. Okay, so I hope you're following along. It's always good practice, class, to at least take a look at what's inside a package. For example, let's take a look at car. Okay, let me look for that car. All right, here. And then so this is companion to applied regression. In fact, there's this also package car data. There are data sets there that you can use. Okay, so let me show first the car data. Okay, so you can see here there are several data sets here that you can use for regression. Okay, there's prestige now, prestige of for example, salaries for professors. This is at 2009 to 2009 9-month academic salary. Okay, 397 observations with 6 variables. Rank, discipline. Okay, that's just an example of. But kindly check first if you'll be able to use this. Okay, so this is the salary. Maybe you can regress salary on the gender, the years of service. This is just like the hourly wage, but this time it has something to do with the salary. Okay. Anyway, back to what we were looking at. Car. So this is packages. So this is definitely a package. Okay, companion to applied regression. All right, so let's take a look at the description. Not the description, the user guides. Okay, but this can be found in, for example, here, PDF DAO. vignettes lang to. No? So let me go back to the description file. Okay, not this one. Okay. Anyway, guys, you can easily look for the car package and the functions that come with it. Okay, for example, ito, no? Yan. Ito yung mga functions niya, no? Added variable plots, ito. Maraming functionalities to, no? So car is one of the most popular package as far as doing linear regression model is concerned, and also as far as diagnostics. Ito yung influence. Mamaya gagamitin natin ito. No? Influence plot. When we deal with the outliers and when we want to see if a particular observation influences the results of your regression model. Okay, so this is a staple. This is a staple package in econometrics or in particular regression. All right, so let's go back to our resource. Okay, first, we're going to take a look at unusual and influence data. So let's first take a look at our data set. So there are three types of data here: outliers, leverage data, and influence data points. Okay, so it gives this definition that an unusual or influence data is a single observation. Okay, it's an observation that's substantially different from all other observations. So medyo kakaiba siya, no? So outlier siya, medyo iba siya, no, dun sa other observations, which can make a large difference in the results of your regression analysis. So the presence of this influential data can largely affect, okay, the results of your regression. Now, iba yung outlier, no? Yung outlier may be different from the other observations, but it does not affect your regression outputs. So here in linear regression, an outlier is an observation with a large residual. So meron tayong model, meron tayong linear regression model, and if we compare the actual data point with the predicted value, okay, with our fitted value, the residual is quite large in comparison with the others. It is an observation whose dependent variable value, okay, ito yung actual value niya is unusual given its values on the predictor variable. So masyadong malayo yung predicted value at saka yung actual value. Okay? So kung tama naman yung pagkuha ng observation, kung tama naman yung pag-record niya, then okay lang yun. Ibig sabihin talaga medyo kakaiba yung observation na yun. No? An outlier may indicate a sample peculiarity. So talaga sigurong kakaiba lang siya. No? Or pwede ring data entry. Baka nagkamali. So instead of, let's say, na-i-record 1,000, yung pala 100 lang. And because of that, yung residual niya, yung error term niya, yung residual, is really very big. So perhaps it was caused by a data entry error, which in that case should be corrected na lang, babaguhin na lang. Pero kung hindi naman, talagang tama yung siguro peculiar lang yung sample na yun, observation yun. Okay? Kasi may mga ganun talagang tao na, kunwari, we rendered a survey, tapos medyo kakaiba yung taong yun. So yung responses siya might be really different, which in that case, siya, parang outlier siya. So pag nag-regression tayo, tapos kinompare natin yung actual value with the predicted value, medyo malaki yung yung residual niya. Okay, so that's an outlier. Now, outliers does not necessarily affect yung regression coefficients natin. Malaking residuals niya, pero hindi siya ganun kabigat para ano, para maiba yung ano, yung regression output natin. Okay, let me, sandali balik tayo dito sa ano, sandali. Okay, let me just illustrate that. Mag-annotate lang ako. Bibigyan ko ng example nun. Okay, so we have this. Ito yung data points natin, kunyari. Ano na lang. So, mabilis. Tapos meron tayo dito. Maybe here. No? So if you can see here the data points, meron dito at saka meron dito. When you regress this, malamang parang ganito din kakalabasan yan. Okay? So this is your predicted value and this is your actual value. So you have here your residual, di ba? Malaki compared to the others here. Ito din, no? Medyo relatively malaki. Okay. All right. Now, this might be this is an outlier kasi okay, of course may statistical test pa niya no, kung outlier nga siya, no? Okay, kasi medyo malaking residuals niya. Now, it's different from an influential value. Kasi si influence points. Okay, sorry, maliit yung space na. Let's say hindi na kinaya ng space. Andito siya, no? Andito yung influential points. So, be couple, no? So this might be an influential point. Bakit? Kasi yung regression natin, pwedeng, kasi because of this presence, pwedeng umano siya, gumanto siya. No? If these points were not present, then the regression line could have been like this. No? If you notice, yung slope natin medyo naiba because of this, let's say, some data points which are here. So this is what we call an influential data point. Ito naman outlier, no? Outliers to. It does not necessarily affect the regression line. Meron siguro konti lang. Pero ito, makikita natin, if these two were not present, malamang ganun pa rin yung regression line natin. It would not have impacted the regression lines by a significant amount. On the other hand, itong points dito, couple of points here. Okay, if this were not there, the regression line would have been like this. But because of this, it affected the coefficients of the regression line. So this is an example of what we call influence points. Okay, vis-a-vis as compared to your outliers. Okay, clear natin to. Balik tayo dun sa, let's go back to our, asan na siya? Okay, so aside from outliers, we also have leverage. No? Ano naman tong leverage? Extreme value on a predictor variable is called a point with high leverage. Leverage is a measure of how far observation deviates from the mean of that variable. Okay, so quite similar to outliers. It's an extreme value on a predictor variable. So ito, yung leverage points, guys, ang ano dito, ang medyo extreme, yung predictor variable. Yung mga independent variables natin. Okay? High leverage. Yung outliers, yung residual yan. No? Kino-compare natin yung actual data points and your predicted value. Yung leverage naman, yung value to ng independent variable natin. So, di ba yung independent variables natin, pwede natin kunin yung mean niya, yung average. Okay? And this particular point in your independent variable is very, very far from your, okay, deviates from the mean of that variable. Okay, importante din malaman to kasi these leverage points can have an effect on the estimate. So possibly, yung leverage point na yan can also be an influence point. Okay, which brings us now to the third one. An influence point is an observation that's said to be, if removing the observation substantially changes the estimate of the coefficients. Okay, and ang sinasabi nila, ang influence point daw, it's a combination of your outlier and your leverage, product of leverage and outlierliness. Okay, so we have to understand, guys, these concepts. Very critical sa atin yung influence, no? Influence points. Kasi yung influence points ang nakaka-affect ng model natin. Okay, so let's take a look at this. Okay, so we're not going to use his data, no? Gagamitin natin yung model 5 natin. So ito, nag-create sila ng model M2. Okay, and then, so let's run this, guys. Saan natin? I-apply natin to sa ano natin, sa model natin. Okay, dito, scatter plot daw ng API sa kanila. This is your dependent variable. Tapos sinama yung mga in our case, isasama natin. Ano isasama natin? Sige, let's copy this. Okay. Hindi ko na makita yung ano ko. Nasaan na yung arc ko? Nagtago na yung arc ko, ah. Wait. Oh, dami kasi naka-open eh. Okay. All right, so let's of course, class, you can copy the notes. No? Wala naman notes na ano dyan. So let's create a scatter plot. Scatter plot for, although we did this before already, hourly wage and the quantitative predictors. Kasi hindi natin pwedeng gamitin, hindi tayo pwedeng mag-scatter plot for ano for gender and civil status kasi ano sila, no? Kasi categorical sila. So we can just do that for, this is your dependent variables, hourly wage. Okay, plus ito, itong dalawa lang, no? Okay, if you try this, no? Control C, Control V, and our data is wage. Okay, so madali naman, guys, i-adjust kasi alam naman natin yung data natin, no? So dito, scatter plot matrix, hourly wage, education, tenure, and then we added genders and civil status. Let's see what happens. Okay, so nag-error siya, di ba? Kasi hindi nga pwede yung ano, hindi naman tayo pwede mag-scatter plot ng categorical variables or factors. So we're just going to create the scatter plot for So bali dalawa lang yung ano natin, no? Okay. All right. So we can see here, ito yung hourly wage natin. And then this is the scatter plot of hourly wage versus education. This is a scatter plot of hourly wage and tenure. So we're really interested in this one. And we can see here that, okay, we did this before, di ba? Nag-kinorelate na natin to. And nakita natin na si hourly wage is if I recall, almost 0.5 yata yung correlation ni hourly wage at saka ni education. Si hourly wage at saka si tenure, medyo mas mababa, no? Okay, so just a quick review and then also learning a particular function. All right. So we're just following class. We're just following the reference here. Okay, and I'm also teaching you how to do this. Okay. So dito, kikita natin sa kanila may potential problem. Ano yung mga potential problem nila dito? May mga makikitang either outliers, di ba? Malalayo, di ba? So if you take a look, for example, at enroll, no? Si enroll, let's go to our, okay. Si education. So 1, 2, 3, 4, 5, 6. Okay. So education, okay, I'm trying to decipher. Yung pairwise niya, hourly wage and education. Ito education, hourly wage. Okay. So it did not give a plot for it. This is si hourly wage nasa y-axis, si education nasa x-axis. For this one, and then reverse lang to eh. No? Reverse lang. Si education dito yung, wait. Education dito pala, sorry ah. So ang position ng education dito, ito. So y-axis siya dito. Tapos dito, x-axis si hourly wage. Dito naman, here in this plot, hourly wage is, ito siya, nasa y-axis siya. Si education nasa x-axis. Which is what we're interested in kasi ang hourly wage natin, ito yung dependent variable natin. And we always plot the dependent variable sa y-axis. Okay. Alright. Tapos, ito, this is hourly wage and tenure. No? Ito yung correlation ng dalawang independent variables natin. Okay, but if you can see here, guys, yung mga plots niya, di ba may mga, kasi ito yung ano eh, ito yung regression line natin. No? Ito yung regression line natin. We can see here some outliers. No? Whether these outliers are, whether, hindi natin dito makikita yung influential points. No? Kasi influential points, we can only get that, yung ano pala, yung leverage points, we can only get that by plotting by comparing the individual independent variable education and tenure with the average. No? Doon natin makukuha yung leverage. And then yung influential data points, there are ways to do that. There are ways to determine kung influence siya using, for example, DF fits, DF beta, using Cook's distance, which we're going to discuss in a while. Okay, so dito makikita lang natin outliers. No? Bakit? Kasi ito guys yung regression line, itong blue na to. And you can see here, okay, these are the actual observations. This one, this particular point, okay, compared to your predicted value. So malaking residuals. No? So where the residuals are substantial compared to the others, those are what we call outliers. Pero there's also a way to compute. Kasi ang question, ito ba outlier to? So how do we determine if it's an outlier? There is a way to compute that. Okay? Okay, so let's continue. Okay. All right. So dito, ang gagawin niya dito, so tingnan natin dito, no? So the graphs of API with other variables show some potential problems. So using this, ang API niya yung yung dependent variable, no? So API compared to enroll, so we're going to use this plot. Okay, ang gagamitin ng mga plots guys ay API as far as this is concerned, no? API with enroll, API with meals, and API with full as far as their data is concerned. Ito yung plot na titinan kasi we're correlating the dependent variable with the independent variables with the dependent variable on the y-axis. Yan. To see API dito, no? Y-axis yun. Okay, so si enroll, makikita natin guys, ito yung regression line na yan, itong blue na to, no? This blue one. And then we can see here that there are some outliers. Kasi malayo itong observation na to, malayo sa regression line. And you can see here this confidence interval, itong dashed line na to. So this is really an outlier. No? Ito din as far as this data point is concerned, outlier din to, no? Okay, and also these points, no? So we can see here outliers. So the plot will allow us to see if there are presence of outliers. However, outliers does not necessarily equate to influence. No? Hindi pa kagad ganun. Okay, we will go over some graphical methods to identify influence points and potential outliers. Gagamit din tayo ng ibang graphical methods. We're not going to discuss and justify underlying methods and formulas here. So hindi natin titinan yung formulas. Okay? Titinan lang natin yung method na ginagamit sa R. Okay, so how can we define outliers? We can use the studentized residuals. Okay, so sa R, madali ito. Hahanapin lang natin yung R standard na function. Okay, so sabi ko, di ba, how do we determine if a particular observation is an outlier? Okay, there are several ways. You can use two keys, yung sa first quartile, second quartile. You can use that. Di ba yung IQR? Yung lalampas ng 1.5 IQR, it's quartile 3 plus 1.5 IQR. If you recall that class, yung points that exceed that, above that, or points below quartile 1 minus 1.5 IQR, which you learned in your basic stat, they are considered also as outliers using the two-key method. Ito naman, ang gagamitin natin dito yung R standard, no? So let's copy this. Copy na lang natin to tapos i-edit na lang natin. Okay? So, ang challenge sa atin ito, dapat may edit natin to kasi yung model naman natin iba, no? Okay, then I'll Control Alt I, and then I'll copy the text. And what we're going to do is we will modify this. So dito nag-create siya ng isang object residual that student types, and the function used is R standard. So this will be model 5. Okay? Galing sa model 5 natin yan, no? Student types residual stored in the vector. Okay, if you recall, names dollar model 5. So ano ba yung laman ng model 5 natin? Oops, sorry. Mali yata yung function ko. Name ba? Wait. Sorry. Kalimutan ko yung ano. Do I have my model 5? Yeah, I think I have my model 5. Mod 5 pala. Ano ginamit ko? Oh, dito na yung model 5. Okay, saan na yung si model 5 natin? Asan na dito yung R standard? Okay, sige, i-run muna natin, ha? Let's run it first. Sorry about that. Okay, so let me, okay, we will have to adjust this, guys, kasi hindi naman pareho yung data natin. Ito muna. Let's create and let's print this. Okay. Yung first 6 na lang para hindi masyadong. Okay. These are now your studentized residuals. Now, iba siya, class, iba siya dun sa ano sa residuals. Okay? Kasi yung residuals natin, ito, 0.126, 0.1257. Yung studentized residuals natin, iba. So standardized to. Okay, it's standardized. It's just like di ba yung how do you standardize? You get the value of the residuals minus the average divided by the standard deviation. So that's the studentized residuals. All right? And then ipa-plot natin to. Okay, so let's pwede na pala sana dito to. Dito na lang. Okay, then let's plot this. Let's see, using the object that we created, res.std, giving it a label, standardized residuals, and let's give a limit to the y-axis, negative 3.5, 3.5. It can be 4, 4, kasi di ba yung standard deviations. Okay, so we're using the standard deviations, negative 3.5 up to 3.5. So if we plot this, Control Enter, okay. Okay, let's see if pwede ba natin idugtong dito yung ano? Huwag na lang. Sige. Okay na yan. So what do we find here? Sa our studentized class, meron tayong mga points, ito mga points na to, no? Na around 3 or more than 3 standard deviations. So pag greater than 3 standard deviations, this would be considered as outliers. No? So may mga points dito, and we can identify them later, that are way above, that are higher than 3 standard deviations. Dito sa baba, wala masyado dito sa negative. Pero dito sa positive, there are some data points that are more than 3 standard deviations. Okay? Ito yung gusto kong gawin sana. No? And let's add this horizontal line. Okay, let me just okay. So ang gagawin natin, dapat magkasama to dito. No? So I'll just copy this, Control C. Okay, let's run this. So i-run yung standardized residuals at saka yung horizontal line. Okay, so meron tayong horizontal line sa -3, sa 0, at saka sa 3. Line type will be dotted line lahat na to. So let's run this. All right. Ito yung result, di ba? So we have here horizontal lines. Okay. Pwede yata lagyan natin ng color dito. It's equal to red. Let's see. Para mas apparent siya. All right. Yan. Okay, so we have here a horizontal line at the 0. Ito yung 0 standard deviation, no? Tapos dito -3 at saka dito +3. So as I mentioned a while ago, there are residuals that are more than 3 standard deviations. Okay, that could indicate that these are outliers. Diba? Kasi ano ba yung outliers? Outliers are residuals. Okay, bali ang outliers, they come from observations that have large residuals. Okay, so itong point na to, ang residual niya is 3 standard deviations away from the mean. So malayo siya, no? Malayo yung mga observations na to. This pertain to observations, the residuals of the observations. Okay, pause muna ako, class. So paki-chat nga please kung so far okay tayo. Clear ba so far? And then of course hindi natin matatapos to, no? So your assignment will be to go over this. Ang challenge nito kasi iba yung data niya. Pero kaya natin yan, guys. Alam naman natin yung M2 niya is our mod 5. Okay, so you just follow along. Okay, maiksi lang din naman. And then aabot yan dito sa homoscedasticity, sa linearity. Okay, so your assignment will be on your own to copy the code and then modify it according to our model. Okay. So clear ba so far, class? Paki-chat naman kung may questions. Thank you. All right. Good. I specifically chose this reference kasi I like the way it was constructed. The other reference kasi medyo hindi siya organized. So this reference yung ginagamit natin ngayon, I find this to be one of the most organized, no? Tsaka yung language niya easy to follow naman. At saka besides R pa yung ginamit, no? All right, so let's now go here. Di pa tayo tapos dito, no? Okay. All right. So dito we're creating an object called index, and then it tells us to identify those points whose standardized studentized residuals are greater than 3, and those that are less than 3. No? Okay. All right. So let's put this into a code chunk. Okay. So ito madali namang intindihin kasi gumawa lang tayo ng object na index. Tapos ano yung laman ng index na yun? Which the residuals STD, that's the object that we created, di ba? Is greater than 3 or residual, that's ortho, di ba? Or yan, less than 3. So let's run this. And i-print natin kung ano yung index. Okay. So ito yung mga index, no? Wait. Magpiprint na yata siya ng on his own. Okay. Index. Hindi siya nag-print, no? So let me just run, print natin. Just type index or ginamit niya yata print index. Pareho lang yun. Yan. Dalawa yung pag-print niya, no? Okay, so ito yung mga observations that has studentized residuals that's greater than 3. Observation 15, 16, 59, 66, 112, etc. Okay? So ma-identify natin kung ano yung mga observations na yan na may studentized residuals na greater than 3. Okay. All right, and then here we add hindi school name to, no? So iba yung ano niya eh. Add the observation number. May name kasi yung data nila, no? Number. Next to points to have extreme value. So let's see. Text index. Baka hindi natin pwede magamit to. Minus 20. Minus 20. Labels. S number. Okay. Labels. What's S number? Okay, ito yung challenge, no? Kasi iba yung data natin. We're just using this pattern. So index minus 20. Bakit minus 20 siya? Okay, ang lalabas kasi dyan, S number. Ano yung S number? Is this a function? Okay, labels is equal to, sige, tingnan muna natin ha. Let's try to see how this will run. Text. Error tayo, no? Kasi hindi niya ma-recognize itong D. Is this mod 5? Kasi sa mod 5 ba may, parang wala namang S number dun sa ano. Okay. Error pa rin, no? Alright. Okay, so sige, i-skip muna natin to, no? I don't know what this negative 20 is. Okay, so sige. Let's skip this first. Lalagyan ko lang ng ano to. Ibig sabihin, we have to validate this kung ano to, no? Alright. So let's not, anyway, na-identify naman yung mga names. Ano? Ang gagawin lang siguro nito, dun sa plot natin, here, in this plot, i-identify niya kung ano na number to. Okay, and there are other functions that can do that. Maganda kung naka-identify dito, anong observation to? Anong observation to? Okay. All right, let's move along. Okay, print na, no? And then, print school names of points that are out of bounds. Itong 211 nila, D. Print D as number. Okay. Sige, hindi pa natin na-decipher itong ano, no? Itong S number na to. Okay, let me check this. Hindi ko, first time ko lang din nakita itong S number na to. All right, so let's take a look at this. We should pay attention to studentized residuals that exceed 2 or minus 2. Dito nga, mas conservative eh. Plus 2 or minus 2. And get even more concerned about residuals plus 2.5 minus 2.5. And yet, more concerned about residuals that exceed. Ito na yung ultimate, no? Plus 3 and minus 3. These results show that number 211, school number 211, is the most worrisome observation. Kasi si 211 plus, nasa ano siya, plus 3 standard deviations away from the mean. No? To get at least that we use the externally studentized residuals by excluding each point from the data to calculate standard deviation of the residuals. All right, so ang susunod na gagawin dito, we're going to use ito. This is very popular, yung outlier test. Ipapakita dito kung outlier ba, ano yung outlier. Okay, so let's run this. Here we will be able to identify anong mga observations ang outliers. Okay, so we can copy this. Actually, you can copy this if you want. Copy nyo sa notes nyo, no? Para doon, ando doon yung code, tapos may explanation kayo. Okay, and of course, ayusin na lang yung ano, yung model. So I'll just copy this. Yan na lang. And then si Bonferroni test, ginagamit yan para malaman natin kung outlier yung isang observation. Okay, so this is mod 5 natin, ano? Okay. And then let's run this. And then mod 5. Oops. All right. Outlier test. Okay, this is from the car package. Ano nila natin? Okay. Outlier test. Ayan, no? This one. Outlier test. Bonferroni outlier test. Meron din si OLSRR yan, guys, no? So we can also check this. So ilalagay ko lang dito yung ano yung package niya, yung namesake niya para alam natin na itong outlier test na to. In fact, we can copy this. Para lang may comparison tayo ng output, no? All right. So let's run this first. All right. Makikita natin dito, class, yun, no? So observation 15, 59, 229, based on the Bonferroni test, there were 6 observations whose are studentized, no? Where ito yung mga are studentized na figures niya. Okay, and then we have this Bonferroni P. So ano yung binibigay sa atin ng Bonferroni P na to? What does this tell us? Okay, so let's go to the help. Reports the Bonferroni p-values for testing each observation in turn to be a mean shift outlier based on studentized residuals and linear t-test, generalized linear models, and linear mixed models. Okay, so ito yung ito yung syntax niya. Tapos may example dito, no? Okay, in fact, we can run this. Okay, ito. All right, so let's take a look at the explanation here. All right, so dito yung result niya, you notice that the p-value is less than 0.05. Okay, so this is a test of hypothesis that we do not have outlier versus at least we have one outlier. So ang tinetest dito, walang outliers. Okay? Walang outliers. Tapos, ang alternative hypothesis that we have at least one outlier. Okay, so ano yung result niya dito? Hindi niya in-explain dito. Okay, yun ang kulang dito. But, okay, that's why I said, time na, no? That's why I said I do not just depend on one. So dito, the explanation here for the outlier, I think is better. Okay, so let's go here. Yan, outlier data, no? So ito yung example niya. These are your observations. Tapos meron ka dito. Now, the presence of these observations will affect your regression model. Kung wala ito, yung regression natin pa ganun lang. Pero because of the presence of this, mag-shift pababa yung regression model natin. Okay, ito, no? Yan. Kung wala. Pero kung ando dun siya, malamang, hindi na pinakita dito, no? Mag-shift yung model natin. Okay. So, asa na dito yung ano? So may ibang ano dito, class, no? May ibang functionalities na wala dun sa isa. Kaya that's why it's best to do not just depend on one. Wala ba dito si Bonferroni? Wala dito, sorry. Ito. Here, guys. Ito. Here. It's 1 minute before time. So, tapusin ko lang to, guys. There are a number of ways to examine outlying observations. Okay, so one of the first things we can do is to perform a Bonferroni outlier test. So it uses a t-distribution to test whether the model's largest studentized residuals values outlier status is statistically different from the other observations. So titingnan niya yung largest na studentized residual values is statistically different from the other observations. A significant p-value indicates an extreme outlier. So kung significant yung p-value, ibig sabihin ng class na outlier siya. And it warrants further examination. So ito yon, no? The outlier test na ginawa natin kanina from the CAR package. All right? No studentized residuals with Bonferroni. Okay, ito. So dito, ito yung null hypothesis natin. Okay, and the p-value is 0.00425, no? So, anong conclusion natin dito? We reject this null hypothesis. Okay, na walang studentized residuals less than 0.05. Okay, ibig sabihin, outlier siya. Okay, so in our case, ano nangyari? Yan. Okay, hindi nagkasya sa isa. So ito yung mga p-values natin, no? So we reject the null hypothesis na hindi siya outlier. So these are outliers. Okay, so these are outliers. And lastly, kasi time na, sorry guys. Ito na lang. We can use the OLS-RR package. All right? So ganun din, ano? Ganun din yung output niya using the OLS-RR. So ito tatlo nga lang, studentized residuals, an adjusted p-value, and the Bonferroni p-value. Okay, so we base it here dun sa Bonferroni p-value since the p-value is less than 0.05. So we reject the null hypothesis na hindi outlier si 112. Outlier to. Outlier tong mga points na to which ang susunod na step niyan, titingnan natin kung influential siya, which is now part of the ito, no? Yung dito naman, i-check niya dito kung kung influential din siya, pati dito sa reference natin dito. Okay? So your assignment, guys, for Tuesday is to continue with this. Dito naman titingnan niya kung kung outlier. Kasi kung outlier naman na hindi naman influential, okay lang 'yun. Pero kung outlier na influence point siya, yun na yung pinaka-challenge natin. So kindly follow along this one, guys. Ito na yung Cook's distance. No? It will now identify kung influence siya. Ayan. So you'll be able to generate this with our data. Okay, and also this influence plot. Okay, the larger the circle, ibig sabihin, the greater the influence point. Okay? So kakayanin nyo na, guys, yung pagsunod dito, test for normality and also the multicollinearity of the VIF. But we'll still discuss this in passing na lang. So I will assume that you have already done this, so that comparison na lang tayo next meeting. Okay, do I have your commitment, guys, to do that? Paki-chat naman please kung yes, yung commitment nyo to follow along this one and read through the notes. Hello? Okay, thank you. So recitation tayo next meeting. No? I'm going to ask some of you to show your, and maybe I'll ask you to submit. No? Isasubmit nyo. Sige, gagawin ko na ng assignment. On your own, follow along, gawin nyo sa M5 para bonus points natin sa exemption. Okay, I'll create a folder for the assignment and you follow along. You can mix it with the other one. And of course, you can also do that with using other references. Okay, I'll create the folder later. Thank you, guys. Thank you. Due on 7:30 ng ano. Okay, Cuthbert. Okay, sige. Okay, thank you so much, guys. I will stop recording now.